Bueno, buenas tardes a todos. Muchas gracias por acompañarnos en otro Conversando Concisos. Ya hemos estado fuera de esta serie las últimas 2 semanas por asuntos, conflictos familiares, así que mil disculpas a todos y verdad, muchas gracias por acompañarnos. Mi nombre es Edgar Rojas desde Estados Unidos y Andrés Almanza desde Bogotá, ya que hace una aparición la famosa ruanita una vez más, debe estar frito por allá.
Claro. Sí, sí, no, hoy ha sido un día, buenas tardes Edgar y buenas tardes a todos los que se van sumando. Hoy ha sido un día de contraste. Amaneció haciendo un frío terrible, ya ha bajado, sin embargo sigue haciendo frío,
No,
¿sí? Entonces, pues bueno, y
ahí
amaneció
va.
lloviendo
Ah, no,
durísimo.
eso, la
¿Ya?
lluvia en Bogotá es horrible, llega hasta hasta
Bogotá
los
hizo lluvia.
huesitos,
Sí,
pero bueno.
exacto, que tú sientes que te está calando por todos lados.
Pues Andrés,
Bueno,
hoy tenemos un invitado especial que es Ming Chao de Tufts University acá en Boston. Mientras esperamos a que él se conecte, supuestamente no había recibido el enlace, creo que Tufts University lo bloqueó, quién sabe. Entonces vamos a esperar a que entre. Mientras esperamos, la invitación es a todo a la próxima semana, ya, fue madre. El
la
28 y
otra semana,
29,
sí, señor.
sí, miércoles y jueves de la próxima semana, el Congreso de Inteligencia Artificial tiene muy buenos ponentes. Estuvimos conversando, Andrés, rápidamente acerca del nivel de los ponentes, ese poco de
Sí.
doctorados. Parecemos una universidad de PhDs aquí. Impresionante el nivel de los ponentes que nos van a acompañar, ¿no?
Sí, sí, es cierto, tiene una plantilla muy interesante, pues, académicamente hablando, unos muy bien preparados. Pero
Sí.
lo que hablábamos en su momento es que, por ejemplo, en ese tema particularmente inteligencia artificial, pues hay que recordar que este es un tema que surge académicamente, ¿no? Y que se ha venido desarrollando en los primeros años de su historia, solo desde la academia y ya después cuando se empezó a materializar o a volver real a nivel de la práctica comercial, pues obvio que todos esos doctores y que siguieron desarrollando doctorados y muchos más que vienen en el camino, pues ya tienen cómo hacer aplicación en el mundo real. Pues cuando digo en el mundo real, pues pasas de la investigación a,
Ok,
a, a
ahí
la...
está, men.
Sí.
Sí, no, entiendo lo que estás diciendo. Sí va a ser 2 días llenos de mucha información. De verdad, si quieren aprender acerca de inteligencia artificial, del uso real de inteligencia artificial, la invitación es que nos acompañen. Ahí está la dirección iacongreso.com. Eh, yo estoy utilizando esos 2 días, Andrés, para tomar toda esa información y aprender bastante y comenzar de un nivel ya mucho más avanzado, diría yo, porque de nuevo es una oportunidad única y gratuita y una oportunidad única de escuchar y aprender de estos expertos de inteligencia artificial y la aplicación de inteligencia artificial en diferentes
Ambiente, sí.
mercados, ambientes, exacto, muy interesante.
Y
Ok, aquí,
verticales, sí.
exacto. Aquí tenemos al caballero Ming Chao, entonces cambiamos el chip al inglés. Así que
We're
eh,
doing Duolingo today.
we can do Duolingo, yeah.
Nice.
Before we start, Ming, yo creo que yo habilité la opción que si tienen en Zoom, que Zoom tiene una opción de traducción. Yo creo que yo la habilité, si la pueden, si saben cómo trabajar eso y tienen la versión de Zoom más actualizada, creo que le permiten seleccionar traducción al español si no lo entienden. Si no, tranquilo, Ming habla muy claro, muy lento. Él es un profesor, entonces va a ser una conversación muy interesante y la conversación es acerca de qué ha cambiado en nuestra industria en los últimos 10 años. Y se la coloco rapidito antes de que entremos con Ming. Ming nos va a compartir una presentación que él dio hace 10 años. Y vamos a ver, y las profecías o lo que él dijo que venía en el futuro, vamos a ver dónde estábamos hace 10 años y qué es lo que había dicho Ming hace 10 años acerca de la industria. All right, Ming. So thank you so much for joining us. I just set up the whole, the presentation, the talk, and it's about a presentation that you made 10 years ago. And we're going to find out where we were 10 years ago and what were the predictions that you had made 10 years ago about the industry. Did I get it right or?
Well, it wasn't. It wasn't 10 years ago. You could do 10 years. I mean, that would
Okay.
still work. It would still work.
So this was how many years?
It was 2017 to that.
4 years. Okay.
But
Oh,
what's
4 años.
sad is, here's the sad thing. You could actually go back even longer than 4 years. Like
We did.
turn back the clock. I'm sitting down here and I'm thinking, I started my cybersecurity. I got into cybersecurity in 2004. I had no idea that cybersecurity was a thing in 2004. That's when I started learning that this was a career path. And I remembered in 2004, I went to a training and we learned about, again, keep in mind, this is 2004. We learned about vulnerabilities such as cross-site scripting, SQL injection, buffer overflows.
Hold on a second, Mick. Todos los que están escuchando deben estar haciendo lo mismo que está haciendo Andrés. Sí.
Yes, of course.
I mean, those are things that are still around. Buffer overflow, we all know them in English. We don't have to translate those, right? XSS, buffer overflow. What were the other ones that you said, Mick?
Cross-site scripting.
Cross-site scripting.
SQL injection.
SQL injection.
I didn't even mention a thing about passwords and password cracking.
Oh, but in those days,
yes.
That's what everyone was working with. Jack the Ripper, wasn't it?
Yes.
That
John the Ripper, still, yep, John the Ripper.
And I remember Ming, a good friend of ours that we actually haven't seen him in a while. He was mentioning in those days how he was already using Amazon Cloud because it was new in those days. But a lot of the hackers were doing the same thing. They were already purchasing all of those Amazon CPUs to do password cracking with the dictionary attacks much faster than doing it in their 8 megabit or 12 megabit computer. So
well, that also brings up, I mean, if we're talking about 2004, 2007, that also leads up to something I didn't mention. Well, actually I did in my presentation because it had to do with the cloud, but I remember there was one thing I probably didn't say, but anyway, so I went to my first big security conference. Like the times I went to the security conference was like 2006, 2007, around then. And the landscape this was around the time, I don't know if you remember TJ Maxx, the company.
Yeah. TJ Maxx es una compañía importante acá en Estados Unidos hace muchos tiempos.
They got breached. This was when they finally got breached badly. And TJ Maxx is local to where I live too. I mean, their home headquarters. So that got a lot of attention at that time. Cybersecurity in the news, it wasn't unless you were a company and you lost a lot of money and a lot of data was stolen around then. So that was a big deal back then.
It was about data being stolen more than anything else.
And payments. The other key thing is payment records.
Okay.
Credit cards.
Oh, yes. Well, yeah, exactly. That type of financial information being lost, being hacked, yes.
And that was a big deal. I mean, that was a big deal because it was a lot of financial information lost.
Yes.
So here I am, and here we are in 2021. And the timing of this conversation is kind of interesting because a few nights ago, I didn't know about this, but GitHub published they published an article. Here it is. It's called Our Shared Common Weaknesses, July 13, 2021. And I'm going to share this item. This is the article. It's published by Real GitHub.
Okay.
And I mean, immediately right now, I mean, the big change is, okay, software supply chain security is a challenge. Okay, so that's been a big thing, of course, because of SolarWinds. Software packages go unmaintained, yada, 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 yada. Okay, that seems that, I mean, software supply chain, I didn't see that. We didn't fathom that 10 years, 10 plus years ago. Software packages go unmaintained, wasn't that big of an issue. But if you read the entire article, if you read the entire thing, which is very digestible, like 5-10 minutes to read, and the article talks about common weaknesses and CWE and the vulnerabilities that they have that GitHub has seen quite a bit. And it boils down to, you ready for this? Distributed denial of service.
DDoS, no.
Improper input validation.
Okay, that's SQL, yes.
Cross-site scripting. So here we are. So it's CWE 400, CWE 20, CWE 79. Those are the vulnerabilities that GitHub have been seeing. So I'm reading this and I'm saying, okay, none of this comes as a surprise to me. Like none of this, the entire article, nothing's a surprise. Because each and every article, a lot of these articles on, you know, a synopsis on what happened the previous year, on the year end thing, always talk about the same vulnerabilities. At the same time, what I also find surprising is, here we are, we're still battling these same problems. It's the same old problem over and over again for the last so many years. So I know that, and I did a panel yesterday to high school students, and I mean high school students, pre-college students on cybersecurity. And it was interesting because it's not only because we could give the same presentation over and over again, but some students realize that cybersecurity is still relatively a young field, 20, 30, 40 years old. And I think it's safe now to say that we've just developed some general patterns on what the real big problem nuances are that we're going to see all the time.
Which are the same ones that we've been talking about, the software programmatic errors?
We still see that all the time.
So apart from the DDoS thing, which is more of an architectural thing, right, that we can deal with that, the other ones, SQL injection, you know, invalid input, cross-site scripting, that's part of the, what we are driving, we've been driving towards this for the past 10, 15 years, which is secure code development, right? And we've seen, and we've seen in Latin America, there's a lot of conversations about shift to the left, and how, and in fact, we had one of the co-founders of Fluid Labs here, right? And it was a fantastic conversation that by implementing those type of coding, secure coding programs, Ming, and I'm going to put it in quotes, right? Supposedly, a lot of this very basic issues should be removed. But again, then, you know, OWASP top 10, they've always had the same issues. OWASP top 9 now, at least we got rid of one. But anyway, OWASP top 10 still has those same issues. So, I mean, we're not seeing anything. Is it because we're still relying on older versions of applications that are not fixable? Well, are the newer versions do fix them? Are they I mean, what the heck is going on then? Go ahead, Andres.
That I say that because when I listening in my mind, I say, is the source code and write good code the problem? Is really the big problem that we don't have, or we don't write in a correct way the
or are we trying to shift the blame? Look at Ming smile. What do you say, Ming?
Because all the time you say, oh, that this is we have the same problems, buffer overflows, SQL injection. Even now, you see the same. You see the same. But at the end, you say, it's really a bad source code programmers or programmer that doesn't know. I don't know what is the big problem in this moment that we have in the time the same problem.
So is it a cybersecurity issue or a development issue?
For example,
I'm just like sitting here and it's like when you try to digest a really bad football game and you're just like, what happened? Like, why is this happening? Even though we've invested so much time, people, energy, and all of this, and why are we making these same old mistakes? I mean, we digest that even after a football game.
Yeah.
Even after a football game, we do that all the time. I don't care what team you support.
Yeah, the Colombian national team in Copa America. It was like, what the fuck?
It's like, what's going on? So this is a question that I ask myself all the time.
Mm-hmm.
And there are too many reasons to list. And I'm going to give a quick brain dump on what I feel, given my experience, what I've seen. So first of all, about the old code, as Andreas, you mentioned, the old legacy software, that isn't going away. Let's understand that legacy is not going away. It's a big deal.
Mm-hmm.
You know, if you ever try to rewrite or rebuild a system from scratch, it is awful. Like, no, you don't ever want to do that.
Imagine this in financial industry. This is not possible.
So that's gonna stay. Old legacy code, especially the stuff that were written in the 50s, you know, really early times that didn't have any security model, didn't have any security program. You're going to find stuff there. I mean, so legacy that's one. Am I going to say that's the biggest blame of them all? No, let's not play the blame game on that one. But legacy is certainly there. Percentage-wise, how much of the vulnerabilities is in legacy and old code? Let's not even get into that one. We don't know. We just don't know. What we do know is this. Let's take legacy out of the equation now, and let's take a look at how current software is built now. And the way that software, especially as in the last 5 years have been built, has been a lot of dependencies. I mean, you build any software, anything these days, you're going to use other people's code and other people's libraries. Even 10 years ago, I mean, people would use jQuery. I mean, jQuery have vulnerabilities, but now you have like really large framework like Django, Ruby on Rails. Those are large code bases. Those are not small. They're not like 5K library code. They're like megabytes and megabytes of other people's work. Sure, it makes your development life so easy. So instead of spending 3 years to actually build a system, you could take you 3 months to do. And that's a big shift, systematic shift. And as of recent, dependencies are just riddled with vulnerabilities. They're just riddled with vulnerabilities. And I guess your follow-up question is, why is that? A lot of libraries were built with functionality in mind to do one thing correctly. Security, who knows? A lot of times it's a complete afterthought. You take a look at a lot of vulnerability, is in a lot of third-party libraries. But it gets worse. It actually gets worse than that. If you're a developer, if you're building a product, you're building a system, and you're depending on someone else's work, you're just trusting it as is. So in other words, you have the blind lead the blind. This is it. I mean, you have the blind lead the blind. So that's a problem. When you got one vulnerable component, everything else goes down the drain. I mean, how many cases have we seen, parts of the internet goes down, because there was a vulnerability on X, Y, and Z code, or because someone decided to, I'm not sure if this would even be considered like house security, which realm this fall. Someone decided to pull the vulnerability after the library, the repository. It's like, what?
All the dependencies on that one code, yeah.
Okay, so you have complexity and dependency, awful, like right there. That's why you still have it. You have an education problem. And I can't tell you how many senior developers I talked to over the years. Forget about the 18 or 22-year-old, the young people who are going to school and college. They're not getting this stuff in school. Very few, if any. But what's more troubling are like senior engineers who don't think about things like input validation. And they don't even know that. And I can't tell you how many times I've seen a presentation, I've done a presentation, and I see senior developers say, I've never heard of things like cross-site scripting and SQL injection before.
But again, and that's where the conversation we were having with, what's his name from Fluid Attacks? I forgot his name. Felipe. With Felipe, we're like, should the developers know about security? I mean, it's like, does a brain doctor need to know about how the freaking heart works?
But
it's different specializations.
Okay, so on that note, there is a reason why, and I'll say this publicly.
Yeah.
There are many days that I say, I don't want to be in the computer science field anymore. There are many days I say, I don't want to do this computer science thing anymore, technology.
How many of us have said that?
But it gets better. There's a reason why. I mean, I even tell people, I have no idea if you're talking about things like computing and computing science, I don't even know what it is these days. Because now it has been usurped by cryptocurrency, machine learning, and artificial intelligence, which has its own fair share of problems as well, too.
Okay.
But my problem is this. Here's my biggest problem of all, and I will quote something that Chris Weissoppel has told me many years ago, and I'll never forget.
Chris Weissoppel is a very well-known, what's the name of the company he works for? Veracode.
He also goes by the handle Weld Pond.
Yeah, on Twitter, yep.
So this is what bothers me. Civil and environmental engineering. You build buildings, bridges, all those stuff. This is my sticking point that I have never forgotten. When you are learning civil and environmental engineering, when you're doing buildings, when you are doing bridges and structures, you have to, and I repeat, you have to know about health, safety, critical infrastructure, security, the list goes on.
Okay.
Because what happened if you don't care about that stuff? I'm sure you've been following the news of the Miami building collapse.
Yeah, of course. Yeah.
Okay. And that incidents like that make worldwide news, and for very good reason, because it's life and safety. Like this is a life and safety matter. I mean, no one's going to trust you if you can't build a bridge okay. So if you go to school for civil and environmental engineering, you have to learn about health, safety, critical infrastructure, security, all that stuff. Yet at the same time, however, if you're doing computer science, you can walk away and you don't have to learn about any of that stuff.
Oh, from the security perspective. Okay.
None of it. None. You can graduate in 4 years and learn nothing about security, safety, health, critical infrastructure, none of it. You just take it all for granted. The accessibility of computer science can be really, really good. I mean, if you want to build an app, if you want to build an iOS app or an Android app, all you need to do is to download that's the software to do so, and it's free, it's cheap.
Yeah.
Security tools, largely free as well too, like John the Ripper, or you name it, community version available. So it's great for accessibility. But now, let's make no mistake about it, that source code and technology are very integrated with, critical infrastructure, health, and safety. You take a look at things like pacemakers. You take a look at things like building control system. You take a look at water control system, SCADA system. They all have software. Okay. And what people don't understand is that source code,
That's life.
is critical infrastructure. It's very much like a bridge or a building these days. And that's the reason why I actually, ironically, I told my brother, don't do computer science, do something else. Of course, he chose civil environmental engineering.
It's too much
Because of
stuff.
that.
Yeah, and in fact, Gustavo Camacho, thank you, Gustavo. He mentioned that they should know, the developers or coders or programmers, they should know about it, about security. They should know about the risk that their codes will face sooner or later. Specifically, if their code it's going to be used, as you said, Ming, in critical infrastructure, in water, in electric, or again in building construction, right? I mean, I'm not an architect, but I'm going to assume that a lot of programming code goes into developing the safety of buildings, so we don't have a Miami condo stuff. If that code has issues from the beginning and somebody hacked it, blah, 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 make some changes to it, there goes the safety, the risk associated with it, and it becomes a life and death type of situation.
It has, yep. You see this with airplanes. A perfect example I didn't even mention is what about the Boeing, the Max?
With
right there.
With the
I mean,
code.
I can end my discussion. That was like a pristine example.
Yes.
Right there.
Yeah, with the code failure with, what was it, weight or something like that, and I forgot exactly what it was. But Liz, lawyer Liz, she was mentioning something, and I don't know if it was in jest or not, but a couple of days ago for DEF CON, she was mentioning in a video something about power supplies on airplanes not lasting too much or seeing too much usage, and that they're being used for crypto mining. And I was like, oh my God, power supplies on planes as we're flying being used for crypto mining. Those power supplies should be 100% focused on the task at hand, helping the plane stay afloat. So yeah, I mean, that's a lot of issues. So Ming, you're a teacher, and Andres, you're a teacher. What do you see happening in universities then?
You read my mind, because I use a question for this. What is the reason? Because in the university don't teach to take care about security in code. Because, for example, my example is in the university, the important thing is create the code, but not is necessary secure the code.
Well, so Jorge Gallardo.
Yes,
Jorge.
Yes, but because, yes.
I mean, he makes a good statement. He says developers that he knows all they care is about
coding. But the question is, security is coding too or not? This is the question. Because in United States, in Colombia, in Chile, in whatever place, wherever you want, in the university, maybe, I don't know, speak about your university, but an example in Colombia, here in the university where I working, we have a elective signature about security, but it's not security in code. And the teacher don't say, oh, okay, we have this special.
It's not part of the curriculum. Okay.
It's not common that you can find this. A part of curriculum is not common.
So
security code. No,
so, yeah.
Not called security. And you say in security, you see the principles, blah, 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 blah. And that's it. But it's not common. Even in magister levels or whatever other postgraduate level, it's not essential of whatever program.
Wow. Man, I know you've been saying that because I read your tweets all the time, and you can, and this is one of your main comments, constant comments, is there's no, and you said it before, there's no focus on teaching about secure coding, the risk and the ramifications of insecure code to students.
Mm-hmm.
Okay, so I've been teaching for over 10 years now, full-time at Tufts in the computer science department. And I say that a lot of students take the introduction to security course. Not an issue. That's not an issue. That's not the issue. But where the troubling spot is when students come back, or when 1 to 2 years down the road, when they talk about what they wish they got out of a computer science program, what they wish. Students have always have like by far and away, the comment is testing. How
Testing?
to test and read, testing and read other people's source code and other people's work, using other people's work, auditing other people's work. It's by far and away the biggest thing that people have realized.
That's interesting.
But wait a minute, well, you may be wondering, what does that have to do with security? Well, of course, it has a lot to do with security.
Everything.
What security has to do with it has to, I mean, a lot of what security is correct, and what security has to do with is correctness. Right there, it has to do with correctness in testing. A lot of it. And so a lot of stuff right there, even whether you have taken security or not at Tufts, but the number one comment that people have read, that have said is, I wish we learned more about testing, using and reading other people's code. If you go out in the real world, most of our students go to work at the big places, as you know, the really big, like the real famous places. And they said, almost never you write something from scratch. I mean, you're going to be working with code bases that are like millions, not thousands. Like we're talking hundreds of thousands to millions of lines deep. Like you almost never write something on your own from scratch, which is what school is training you to do.
Okay. That's an interesting point, Andres. I never thought about it. In a real world, yes, it's true. Unless you are, later on in your life, you have a great idea, you get a group of people together, and then you come back, and then at that point you write something from scratch. But that's many, many years down the line. But wow,
that's many years, unless you decide, but it doesn't work out very well, especially if you decide to go the entrepreneurship route.
Yeah.
But you have to build some credibility. If you want to build some credibility first, then you do your own thing. That's what it should be.
Yeah.
But the number one issue that students have said, I wish we learned more about coding, testing, and how to read and audit other people's work.
And let me stop you right there, man, because in a project that I just came out of here at Deloitte, right? Big company, Deloitte, right? Huge company, right? And one of the things that we were working with was exactly doing that. We have a team that's developing code for a client, and then we have a team that's doing the Q&A. I mean, the Q&A, the audit and all that stuff, right? And then, but do you know how difficult it was to find code auditors that knew how to use certain tools to audit and find any issues? We could find developers like crazy.
Oh yeah,
but we cannot find
off the streets.
Right, but we cannot find exactly what you're saying.
So I'm going to say a couple of things to that. First of all, developers are a dime a dozen. I mean, anyone can learn how to code. You can
Yes.
pick up a book and learn it in 10 hours. I mean, I'm just over exaggerating. I mean, hell, there are books that say learn how to program. Programming is not that special. Like, everyone can learn it, anyone can do it, especially nowadays if you have an internet and you have a computer. The problem is, and this is what a lot of companies, a lot of places are having trouble with, how to find good ones, the real good developers that knows like the full stack, who actually know testing, who know security. That's very, very, very difficult to find. I also want to bring up this other issue as well. The problem is, one of the biggest problems with that comment, which is using other people's code bases and working on like production-based system, that's almost impossible to do at a college or university setting, because college and universities they don't have that infrastructure. I mean, only a very, very few schools out there have like major software projects that are used like in the history, like used in mankind. A good example, for the longest time, Stanford had that, Berkeley with BSD, with Linux. Like, unless your program has a significant involvement in a large software project, it's really hard to teach that stuff. It's really hard to teach testing, reading large code bases, and security in the real. The only option that I have seen that is left is to be a part of competitions, like MITRE's Embedded Capture the Flag, or some competition that some corporation offers. That's the only viable avenue that I see in a college and university setting.
Where it forces the students to review code and find any of the vulnerabilities.
That's the only thing that I see left. I'll give you an example. I'll give you a real easy example. Obviously, this is not happening. This can't be happening right now because it will be, a problem. I mean, it's not like any school out there is working on directly with a Facebook code base or the Google code base or Salesforce. I mean, I don't think that's happening anywhere. I would be really shocked if there were schools that were involved in maintaining Facebook. That kind of activity is necessary in order to really learn security and testing and all that. I don't think that's happening. I do know that there are schools that are working on a Linux kernel. I mean, one of them is the University of Minnesota, but they did all kind of fraudulent things, so let's not talk about them. What a mess that was.
Oh my God, they hacked the system. Okay. Hey, before we continue, there's a couple of comments here and questions.
Gustavo Camacho.
No, but first, let's do the Raul Lescano first. Raul, thank you, Raul. Raul is saying that you may include complexities of APIs for interconnected applications and systems, especially now when a lot of the stuff is going into the cloud and it's all
about APIs.
It's all APIs up in the cloud. I mean, that's talking to the CISO from Naranja, Santiago
and
Fernandez.
You consume all the time these APIs from everywhere.
From everywhere. Third-party APIs, which is what Ming started saying. We're not even talking about supply chain.
But issues, this is a supply chain issue in development.
Absolutely,
of course,
absolutely,
totally.
So
I say this is our issue in
10 years.
I don't say that in 10 years, because now API security is one of the things that you have to see.
But that's the other thing. We go back to what Ming is saying, right? A lot of these APIs were not written from scratch. A lot of them are also based on legacy APIs. So they already come by default with issues. I mean, one of the things that we keep saying in the industry, right? Everything is based on TCP/IP. TCP/IP by default is an insecure protocol. So therefore, everything that's built on an insecure protocol by default is insecure. We're stuck with this. Gustavo Camacho says two things. What about labs? Do colleges or university count on them? That's one, right? Ming and you were talking about it. The other one, he's saying, the the specialist shortage then, right? So this is true. There is a specialist shortage, not focused on cybersecurity, but on the knowledge of the developers on how to properly audit other people's stuff.
Yeah. Yeah, Raul's point is actually it gets deeper. Like Raul said, you may include complexities of API for interconnected application system. Actually, now I don't even think that I can't even think of an application or a system that doesn't include interconnected systems, especially anything that's on the web, anything that's mobile. We're not talking about just 1, 2, or 3 dependencies of external API, but we're talking like dozens.
In one simple application, I know, because we're working on something, and I know, right, Andres, one application is using at least 15 plus APIs. And we trust those APIs because we have no choice. Otherwise, we have to recreate the wheel from scratch. We don't have 5 years to recreate the wheel from scratch.
Like if there's one important principle, you never want to reinvent the wheel. Like you never want to do that.
Yeah.
So then we go back to the issue, Ming, and I'm sorry, but the trust. We trust these APIs. We trust that somebody else. We trust that Andres wrote the API and he knew how to develop in a secure environment, or that they applied secure code principles. It's all about trust. And this is what the issue what we have with the third-party risk, supply chain stuff. Walter Galvan, gracias Walter por estar aquí. Hello, I agree with your comments. However, once an organization has identified the importance of incorporating secure development techniques on the developments, which are your recommendations to begin with secure software development lifecycle? So once the company has identified it is very important to incorporate secure development techniques, what are the first steps? What are your recommendations, Ming, for them to start implementing the actual practice itself?
Well, 2 things come to mind immediately. Really 3. Well, first of all, let's take a step back, and do we know of any company that have been down that road before? And the answer, of course, take a look at Microsoft. Microsoft is a quintessential example. I mean, for years, they got a bad rap, and they still do up to this day, of not taking security seriously since day one. It got so bad that Bill Gates had to send an email out to say, we gotta take care about the security problem. And of course, here we are now. If there's one big difference in the last 10, 20 years, is we used to look at Microsoft as a complete joke when it comes to security. Now they're the people who we go to, because they've seen everything and they've been there, done that.
That's true.
If there's one thing that changed. So Microsoft is a very good model of how they did this. Is okay, we've identified that we really need the software security. We need a security model. Well, number one, the first part is, all right, what does they say? You admit that you have a problem. Okay, you have to do that. But the second thing is, okay, what training program do you got? So you have to have, so you got to be some way to get all the ducks in a row. That got to happen. So you got to invest in training and putting all the ducks in a row, make sure that everyone's on the same page. Number 2 is, okay, yeah, training is not just enough, but it needs to count for something, because you don't want to be dangling. What's that thing called? You don't want to be dangling. There got to be a carrot and a stick or something like that. Something like that. There have to be, the right word is really the incentive model.
Incentive, yeah.
Okay, so what's the incentive model for this? Obviously, the easy one is, you got to pay people to do this, but yeah, the incentive could be definitely like performance reviews. Incorporate this into performance reviews. And so,
or your code. So that's a good idea, because I haven't seen that. So if Andres writes a piece of code, well, how many rewrites do he have to do because of security implications. So well, that's pretty good. And
You
then based
gotta
on
have
that,
that carrot and a stick.
yeah, okay.
But number three, the hardest part of them all, I think the hardest part by far and away, is maintaining. And that is the hardest thing, is this gotta be a long-term endeavor. This is not an overnight thing. It's like going to the gym. I mean, how many people say at New
On
Year's
January
Day,
1st, yeah, I'm going to the gym. Yeah.
Your post for the 1st of January.
Yeah.
Go to the gym.
That's true. The other thing, based on personal experience, is the reluctance to start, because you've already did the study and everything, and you have to do it. We have a problem, like you said, right? First step, we have a problem. The next step is how do we resolve that problem? And then you can start to analyze it and come up with the training and security champions and what are you going to do and everything. And then you put a roadmap, and then you realize you're looking at no less than 6 to 8 months to get this implemented in such a way that it becomes a natural process, right? And then you're like, do I have 6 or 8 months? Because a lot of the timing, we all know, it's all about agile. It's all about time to deliver and how quickly can we build, right? So it's all money wise. I mean, we go back to the conversations that we've been having in the past about IoT security. It's all about money. It's not that the technology is not there to make it secure. It's how expensive do you want the stupid thing to be, right?
or how cheap.
How cheap you want it, exactly. So you want cheap, you're going to have some things are going to be cut out. So, but anyway, let's go back to the subject, Ming. So cross-site scripting, SQL injection, no validation, which is SQL.
Denial of service. We didn't even talk about passwords.
All those things we're seeing 4 years ago. We can even say they were seeing 10 years ago.
Yep.
We didn't even talk about ransomware. Where was ransomware 4 or 5 years ago?
So here's what I think. Ransomware really is malware. I mean, malware isn't going
Yes, of course. Of course.
But if anything, the biggest change, I think the biggest change by far and away, which is, I think this is a good thing. I really think this is a good thing, is when you get cybersecurity incidents on the front page of like a world news headline. You saw it with WannaCry. You're seeing it with ransomware attacks all the time now. I think that's a good thing. I think the biggest change within the last couple of years have been, one, cybersecurity is now a day one. It's like on page one, top story in the news. This is no longer, because I think for the longest time, people didn't think that cybersecurity was a serious thing. And there's still people who don't think that cybersecurity is an important thing. They think that the hackers are the people who wear hoodies in the basement. I mean, we've had that. I mean, that there are people with that mentality still up to this day, still.
Yeah.
Let's make no mistake about that. But the other thing is, and definitely from yesterday's conversation with students, is cybersecurity is now a part of international politics.
Yes, it is.
I mean, if you're meeting with country leader X, Y, and Z, cybersecurity now is right up there.
Yeah.
It's now a topic of discussion.
It's first in the agenda.
Yep.
It's one of the points in the agenda.
So let's go there. Let's go in that direction, Ming. So do you think that this thing with cybersecurity, because it's in the news, because it's in the agenda of leaders, country leaders and everything, is there going to be then being led more active from a government perspective, going down and putting penalties, putting regulatory requirements, stuff like that to try and fix some of these issues?
So it's a double-edged sword here. On one hand, on one hand, legislation and policy play a heavy hand. I mean, when it comes top down, it's a very heavy hand. It's a lot of power. Okay. China, for example, does this all the time. If you got to do this or you can't do business, go away. So right there, legislation is a really powerful thing. GDPR came down from the European Union. Laws really, really, really make an impact because it's a law. But there's also a problem, though, with that model. The problem with that model is there's a lot of bad laws as well. I'll give you the quintessential example. I mean, how many governments out there want to ban encryption or want to have a backdoor?
Everybody.
So you have a two-pronged problem here. It's like okay. So one, we can know that legislation plays a heavy hand. Legislation, like, solves a lot of problems, but the problem is also, okay, so while legislation and policies are very powerful, we've seen too many times where people get it wrong, and you solve the wrong problem, you bark up the wrong tree.
Take advantage.
Okay. So here's another good example. I got another good example. Another good example is this. Another good example is, this is something that I saw in the executive order from President Biden. Everyone must use two-factor authentication. Okay, I get that. That's a really good idea. That let's make no mistake about it, that two-factor authentication works. Because it's the only way, because the password can be broken anytime. But the problem is, how do you implement that? What's the incentive model? So that's one. And number two, here's another example that can go easily awry. And you're seeing this everywhere. You're seeing this problem everywhere with legislation. We're going to ban all hacking tools, such as John Lewis.
We saw that in Germany.
We've heard those before, but the problem is, what people don't understand is, a lot of those security tools that are used for bad are also used for good as well.
Exactly. And Gustavo Camacho says, it takes a while to issue a law. Absolutely. It's not like, hey, we're going to have a law and, in 5 days it's done. It's done. No. But, I understand that. But then, if we go with no laws, no regulation, then we have the wild, wild west. You can do whatever you want.
Which we've seen. Which is still going on to a large degree. I mean, you take a look at ransomware. It pays pretty damn well if you're a criminal.
Wild, wild west. I have the biggest guns. I have the most powerful guns. I'm gonna wield it. But if they create a law, a regulation that says, this is illegal, you cannot do this, blah, 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 blah. And then at least there's some regulation in there that people can rely on. At this point, I don't see any, as you said, main incentives for companies to come up and develop secure code that meets minimum requirements. I mean, to do business with the government, you have to be FIPS compliant. What is it? 142, I don't know, what encryption thing. Why can't we have the same stuff for code?
What also doesn't help is, and I keep on thinking about this problem, is the outsourcing problem. Because remember, a lot of code are also not built within your own country. They're built in other countries as well, too.
Exactly.
Some of the work, some of the work that, some of the stuff that we depend on, it may be maintained by one person in the middle of Nebraska or by one person in Kiev. We don't know.
We don't know exactly.
So we have so there's also a boundaries issue here.
Yep. Yeah, it's different. I mean, in the States, the privacy thing that's tried to be GDPR compliant. I mean, as we had one of our guests in the past, she's like, we have in California, we have in North Carolina, we have in Florida, we have in New York, and none of them are the same. They're all conflicting. So it's like, it's a mess. At that point, it becomes too much regulation. Well, Ming, we run out of time.
Yeah.
Appreciate your time here. Really good information. I see Andres is thinking a lot about.
Yeah, I'm thinking as much as Andreas too.
Yeah.
You know what? I did like the CTF idea for universities.
No, but this is a good idea, and in whatever place you try to apply this and work, and this work work, because many people like this kind of competition
challenges.
And yes, of course, students appreciate that.
Yeah,
but it's not common. But the problem is that it's not common. You have to do. It's not. It is not good that if you do one per year, this is not enough.
Yeah.
This is the situation. And I suppose that Ming understand this, because many universities say, yes, CTF, okay, really, yes, one per year. And you say, okay, really nice. But we know that this is not enough. We need more. We need more intensity. Maybe.
Well, you got to start somewhere.
This is the idea.
I mean, if you do one this year and you didn't do it last year, that's one more that you've done already. Before we leave, last thing from Raul Lescano, maybe a possible solution to consider is to have internal or external red teams to test development in the design, coding, testing, and periodical updates, not only for traditional vulnerability threats, but also for privacy threats.
Good idea. That is, I suppose that is a little bit expensive in an organization.
I was going to go back to that.
It's a special.
Who's going to pay for that? That's the first thing. First thing is who's going to pay for that, right? Is that the developer is like passes the bill to the client, and the client is like, I don't want to pay for that. It should be it should already be built in. You're going to tell me security is not built into my application? What are you talking about?
Of course.
I got to pay extra for that?
But this is another idea. You can.
But anyway, Ming, thank you so much.
Thank you,
Andreas, pleasure to meet you.
A quick thing, Ming. I know that sometimes you make some of your courses public to the audience. So if you follow Ming, they are comp116.org.
Hold on. I'm also teaching in O'Reilly, but I also teach with O'Reilly now for boot camps.
Okay.
Nice.
So if you go to comp116.org, si van a comp116.org, clases que da Ming gratuitas. Y Andrés, ¿puedes compartir ese último que él compartió ahí? O'Reilly.
The publisher.
Yeah. Ahí vamos a colocar una más. Y todas estas notas la vamos a colocar en el canal de YouTube cuando lo subamos. So Ming, I'm just letting everyone know, where to catch you for training. So thank you so much, buddy. I really appreciate your time, and everyone, todos, muchas gracias. Muy amable por acompañarnos.
Nice meeting you, Andreas.
Thank you.
Take care.
See you later. Julio 28 y 29, Congreso de Inteligencia Artificial, iacongreso.com. ¿Listo? Muchas gracias a todos. Bendiciones.
Cuídense.
Hablamos.
Bendiciones.